All right. So in this course, you will learn many new terms. Polymorphism and allotropy are two of them. So metals and some ceramics have more than one crystal structure, and this is called polymorphism. And for elemental solids, this is known as allotropy. Okay, for example, let's take iron as an example. And in room temperature, iron has BCC crystal structure, which is body center cubic structure. And if we increase the temperature to 910 Celsius, and BCC return to FCC, which is face-centered crystal structure. By lower temperature to 723 degrees, and by adding iron, carbon, 8% of carbon into iron. As we know, if we mix carbon and iron, you will get steel. So now here's a good example to show you iron could have different crystal structures under different conditions, and temperature is an important one. And if keep rising temperature to 1391 degrees Celsius, and the FCC crystal structure return to BCC's crystal structure again. And what happens if we keep increasing temperature? Let's increasing temperature over 1536 Celsius. Now the BCC will turn to what? Turn to liquid. Now we don't have solid anymore. If iron is in its liquid state, all the atoms won't be in any crystal structure anymore. It will be densely, randomly packed together. So packed. And some interesting perspective from here is, as we know, BCC and FCC has different packing efficiency, and when iron experiences this change of its crystal structure, it also alters its volume. It is because BCC and FCC is more densely packed, and BCC only has the atom in the center, body center, but FCC has atoms at each face. So that would experience a volume change during this crystal structure switch. So that's why when you're heating up a iron wire, you receive volume expansion. That's because of change of